So this is a blow-up of the graph we were just looking at, where this half is the times that are down, and then this half is when the glider is going up. So let's just go and label everything. All right, so this line right here is T1, T2, T3, T4, T5, T6, T7, T8. Great. That's a labeled time graph. Excellent. Now let's see what we can do with this. Over here. Over here. So this is what we need. We need the acceleration down. Well, okay, this equals the change in velocity going down over the change in time going down. Okay, well, this will equal the difference in velocity from A to B and from the change in time from A to B. In other words, this. In other words, this. If we can find the velocity through B minus the velocity through A divided by the time at B minus the time at A. And then it's the same strategy for A up. In other words, that will be the change of velocity up over the change in time up, and we'll get this. In other words, VD minus VC divided by TD minus TC. So let's see. Let's put things together. Let's find TA. Let's find TA. All right. So the time at A, we're going to call the average time in that photo gate right there. Right there. So let's see here. So the time at A will be T2 plus T1 divided by 2. It's the average time. It's the average time. So right here is TA. And then TB would be the same thing. TB would be the same thing, except it would be T3 plus T4 divided by 2. And so here's, take a good look. So here's all the times. TA, TC, TB, TD. Okay, that's nice. That's nice. That takes care of the denominators of the two accelerations we need. And now let's look at the numerators. So let's look at VA. Let's look at VA. Let's see here. Well, it's going to be approximately the same velocity through the photo gate because the time is so short in each photo gate. So the change in distance will be the length of the glider, L, and divided by the time, delta T A. Okay, so let's look at that. Let's look at that back here. How would I find delta T A? Well, that's just this. Between here and here, delta T A. Oh, that's easy. That's T2 minus T1. Terrific. Now back here. Great. So this is the length of the glider divided by the difference T2 minus T1. That's VA. VB is very similar. VB is very similar. The length of the glider divided by T4 minus T3. Now, VC and VD, we have to be careful here because the direction has changed. And because the direction has changed, we need to stick a minus sign here. So minus L over the change in time for VC, and then minus L over the change in time for VD. And that's the data. You take these and you plug it in here, you get your A up, your A down, and from those you find AG and AF. And that's it. So all we have now are some remarks. Be sure that A up is greater than A down. If not, you know you're screwed up. And then AG and AF are both going to be positive values. All right. That's the inclined plane experiment part 1. Now, to do part 2, we need to go back to the inclined plane to get some more data. Let's go. go. All right. Okay, so come here. Take a look at this picture. Take a look at this picture. This is all we need now. We need 4 more numbers. We need 4 more numbers. We need the mass of the glider. Ah, that's easy. That's easy. So we take the glider and we put it on the triple beam balance, and you will need a counterweight because it's a little heavy, and the counterweight will be provided to you in the lab. So that's easy. We find the mass of the glider. That's nice. And now we want to find the distance between the photo gates lowercase d. Okay, so to do that, we got to turn the air back on so we don't scratch it. And then this is what we want to do. Let's see, to find D2, we slowly ease the glider toward the gate. And as soon as this little dot right here goes on, I know I've interrupted the laser. Not yet. Not yet. Steady now. Steady now. Okay, so right there. Okay, and I record that distance down. I record that point down. That's D2. And I do the same thing the other way. Approach from the same side. And then, perfect. I record that down. That's D1. That's D1. Okay, so now I have D2 minus D1. That's D that we need. Okay, and now I need these. I need to find the distance between 2 arbitrary points on the inclined plane. X1 and X2, this distance here, and then I need the heights that correspond with them. H1 and then H2. So to measure those, I just need 2 rulers. 2 rulers. And this is how we do it. I'm going to measure from the 40. Alright, and then we put 1 ruler right underneath it. And then the second ruler, we match it up here. The reason why the ruler is underneath it is it gives us an edge to measure against rather than this rounded surface here. Okay, so then we measure the height, this particular H at this particular X. And then we go find another H and another X on the other side. Let's say at X is 130, same thing. Put the ruler here, put this here, and then find your different H and different X. And then those will go here. Those will go here to find delta X and delta H. And that's the only new data you need. You'll get the times the same way as before on the oscilloscope.